Hello everyone, here's another lesson about slope. If you haven't looked at the previous lesson about finding and comparing unit rate, this could be a good time to do that to get a better foundation before moving into slope for today. But if you've already looked at that, here's our second lesson. Here's your do now. Go ahead and pause the video and work on these three problems. And now that you've completed those, let's go over them. So this first one says, using what we've learned last lesson and what you already know, find the unit rate of this graph. And we know from last lesson that finding the unit rate of the graph, it's finding how many points, it's asking how many points per minute or per 1 minute. We know that unit rate is per 1 unit. And we know that when we do that, we have to take one of our points. I'm going to use this first green one here. You could have used any of the points along the way. And I'm going to divide the y value divided by the x value to find per 1 minute. So our points at that first is 10 points for 2 minutes. And I'm trying to find for 1 minute, which means I can take 10 and divide it by 2, and we know that 10 divided by 2 is 5. So the unit rate here would be 5 points per 1 minute. So hopefully you got that. If you divided this second point, 20 divided by 4 is still 5. If you divided the third point, 30 divided by 6 is still 5. That's why this is a straight line, because the slope of the line is constant. It's all 5. In this second question, it was 50 divided by 2. That slash means division. So 50 divided by 2, we know is 25. And the last one, it says 5 minus negative 2. So I suggested using a number line here because we know that number lines are helpful when adding and subtracting, especially with negative numbers. They can get confusing. So whenever we have addition or subtraction, we can use this number line. We'll always start on the first digit, which is 5. And then it says to subtract. Oh, I know that subtract means to move to the left, but we're subtracting a negative number, which means we have to flip that from going to the left. Now we're going to switch back and go to the right. So instead of moving to the left, now what it's really going to look like is it's going to look like we're adding 2. So we're going to move to the right 2. And we're going to land on 7. So 5 minus negative 2 is equal to 7. And now that we have those foundations, we can move into our lesson for today. Again, this is your standard for today, 8.EE.B.5. That can be helpful if you need to look up other videos or other information about how to work with slope. And then you can also search this objective as well to help you. Our objective for today is I can find slope or rate of change. Those are synonyms, rate of change and slope, meaning the same thing. So I can find the slope or rate of change of a line from a graph or from 2 points using what I know about unit rate. So we remember that slope is the steepness of a line. So this line is going up semi-steep. So this is a positive line because it's increasing from left to right. This would be a negative slope because it's decreasing from left to right. And this, I was trying to make a straight line. It's not exactly straight, but if it was a straight horizontal line, it would be a 0 slope because it's not going up or down. It's just staying at a constant rate. This is information that we went over in our last lesson, in the previous lesson on unit rate. So as I read these, think about the answers, what you would put in here. So remembering, unit rate means per blank unit. The question I put here is how many? Yep, you got it. Per 1 unit. Unit rate is another word for, just like we went over in our objective, it could be slope, or the other word that meant slope was rate of change. And to find slope or rate of change from a graph, we did y divided by x. And that's what we did when the slope was at, or when the line crossed the origin. So let's see what changes when we work today. So this first example 1, I want you to think about what's different between this graph and the graph we had in our do now. I think I should be able to go back and show you. This is the graph in the do now. So you'll see the points and minutes are the same. I want you to see what's different about the line. Well, I see that it's still a straight line and it's still a positive slope. It's still increasing. Like we said, the points and the minutes are the same. Oh, what I see is different, and hopefully you saw this, is that the line doesn't cross the y-axis at 0. This line does not hit the origin right here. Right, we know that 0, 0 is the origin. And this line here does not cross that. That means that the y-intercept is not 0. The y-intercept is actually up at 10. So I wonder if that changes how we find the slope or the unit rate of our problem. So we know that we can find unit rate by looking at any of these points. So if we choose this first point here at 220, we know to find slope or unit rate, we would divide 20 divided by 2, 20 is 20 points, divided by 2 minutes. If I divide that, I would get 10 points for 1 minute at this first point right here. So that would tell me that the unit rate was 10. 10 points per minute. Okay, let's see if that's true at this other point. I'm going to use a different color for this second one. For this point right here, we have 4,30, our x value and our y value. And to divide 30 points divided by 4 minutes, well, 30 divided by 4, I know is not going to be 10. When I solve that, 30 divided by 4 would be 8.5 points per 1 minute. Well, if this unit rate is 8.5 and this unit rate is 10, are these equal to each other? No, they're not. They're not equal to each other, so we make an equal sign and we put a slash through it, which means they are not equal. So this means not equal. So that means I can't do the same thing that I did when it hit the origin. I can't just take the y divided by the x. Hopefully what we do next will look familiar to you. So what we have to do instead is find, this triangle means change in, the change in y. Let me make that green for the y-axis. The change in y divided by the change in x. So what we just did here, this is incorrect. We don't want to do it this way. What we want to do is take the change in y divided by the change in x. So what we have to do is we have to look at the distance that it's moving up the y-axis first. So moving up the y-axis, we are going from, say if we pick these 2 points, remember you can use any 2 points. If I use these two, this first point is at 20 on the y-axis. And what I'm doing is moving up the y-axis until I hit this second point right here. So I moved from 20 to 30. And I know that when I'm finding the distance, I'm finding the difference between 30 and 20. So what I could do here, my first point was, let me color code this correctly. My first point was 220 that I'm using. Okay, that's this point right here. That's my first point. Remember our x values and our y values. And then our second point, we'll make this one a red star. Our second point was 4,30. So what I have to do first is find the change in y, so the distance that it's moving between the two y points. So the distance from 20 to 30 I know is 10, and I can show that this way with subtraction. 30 minus 20 is equal to 10. And then I also have to do the distance moving along the x-axis, moving horizontally, and that's moving from 2 to 4. From 2 to 4. So to find that distance, I'll again start with the red one. So see how we started with the red one and started with the red one? It doesn't matter which one you start with as long as you start with the same one each time. So we have 4 minus 2. That's equal to 2. And then when we divide these, we will get an answer of 5 over 1, or 5. So this would mean 5, remember our numerator was points, denominator was minutes. So our unit rate then would be 5 points per 1 minute. 5 points per minute. So that is how we have to find it when the line is not on the origin. We have to use 2 of the points and find the distance between the y-axis and then divide that by the distance between, or the distance it moves on the x-axis. So the change in y divided by the change in x. Alright, so change in y divided by change in x. That's why we make these triangles, to show the movement, that it's going from 20 up to 30, and it's going from 2 over to 4 on the x-axis. Looking at this second example, let's see what's different here. Oh, I see that this line is still increasing. It's still a positive slope. I see that the line does not cross at the origin. So that means I have to use my change in y divided by my change in x. But what's different here is I don't see dots on this line. So this last example had dots that we already knew. This one doesn't have them. That means I can use any points along the line that I want to. If I pick this point right here, in the middle here, and I try and go down and figure out what number this is, I could estimate this number as 7 or 8, but I don't want to estimate the number. I want to know exactly. So instead of using one between the lines going up and down, or the lines going horizontally, vertically or horizontally, I want to pick one where it crosses at an intersection. So I'm going to use this point. Whoops, I didn't even draw it in. I'm going to use this point. Nope, still not working. There we go. This point here. So that would be at 10 on the x-axis, coming over 10. Then it's going up 300. Remember, this is our x value. This is our y value. For our first point, that's a, we'll make this one red. Okay. And then the second point, I want to go either up or down the line until I find another point. So if I go up the line, oh, here's another cross. I'm going to erase that blue line. Here's another point where I know exactly, if I come down this line, I know that it's at 15 exactly. So the blue one is at 15. And looking across here, I don't have the number written there, but I know that the line is halfway between 350 and 400, which means it would be at 375. So again, if I'm looking for the difference between y, I'm moving up the y-axis from 300 to 375. So 375 minus 300 for my change in y as my numerator, which would be 75. And then for my denominator, I'm moving from 10 and I'm moving over to 15. So again, 10 and 15, those are my x values. again, if I started with, this time I started with blue. This is my blue y value. So I want to start again with my blue value. So I'm going to go 15 minus 10 is 5. So now what I have to do is I have to divide those. 75 divided by 5. Remember this fraction bar just means division. So I'm going to divide 75 by 5. And when I divide those, I'm going to get 15 over 1, which simplifies to 15. Whoops, that's supposed to be a 15. And then what we're looking at here is our y value is cost. So this would be $15. This is talking about linear feet. We're talking about installing a fence. So this would be for 1 foot. So that means our unit rate or our slope or our rate of change, all of those mean the same thing. So every foot of fence costs $15. So $15 per foot. So that's what the slope of this line means. It's going up 15 units up for every 1 unit over. So that's what this 15 over 1 means. This is just showing that you could use different points. So if you want to use this point up here and this point down here, remember I used the 2 in the middle of those. If you want to use these 2 points, that's perfectly fine. You should still get an answer of 15. So see if you can work that problem if you would like, and see if you can still get 15. Last question here, what's different about this one? Oh, I see that this line is decreasing. It's a negative slope because it's going down from left to right. It's decreasing. So I know that my answer, my slope, will have to be negative. So keep that in mind as we're working this problem. So what I did here is I worked out the problem. Okay, so we knew that it had to be negative, and we know that we're still using the change in y, the change on our y-axis, divided by the change in our x, which is along our x-axis, moving from here to here. Right, and I used this red point and this blue point. Where the green dots are, those aren't my actual points, but I labeled them red and blue so you could see which one, where I got the numbers over here, red and blue, from our x value and our y value, x value and our y value. And then same thing, I'm going to find the distance from our y value. So I started here, the 340 comes from the red y value, so I'm going to put that one first. 340 minus 220, and I got 120. And then, remember I said that we have to leave the same number first. So although it looks like we should do 7 minus 1, because a lot of us think the bigger number has to come first, I have to do the same value I put first. So I have to start with this 1 and subtract my other x value, which was 7. So then I got negative 6 as my denominator. When I simplify that, I'm just dividing 120 divided by negative 6. So I get 20 divided by negative 1. And then when I solve that, I just put it over here because I ran out of room. So our slope here is negative 20, which we said at the beginning it should be a negative slope, which means that we must have done something right because it came out to negative 20. But now we also want to think, what does that mean in context? So what it means is our numerator was feet, right? Was feet. And our denominator was minutes. So this person is hiking. Their elevation I see is decreasing because this line is going down. So they are decreasing their height. So the height decreases by 20. It decreases by 20 feet each minute. And if you look at our answer here, decreases we know means negative. So I didn't have to have this negative 20. It already means negative because it says decreases. So now that we've practiced positive with dots, positive without dots, and negative without dots. Now you should be able to, one, remember these as we move into our practice. Slope and rate of change are the same. Rate of change is the change in y divided by the change in x. What that looks like, how I've written that is like with shorthand. This triangle here just means change in x. And on a graph we'll use 2 points to make a right triangle. So now go ahead and pause the video and try and find the rate of change or the slope for each of these graphs. So hopefully you've finished those by now. You've taken the time to do those. I'm going to go ahead and show you what the answers are. So this is the unit rate for the first one, $5 per week. So the unit rate is 5, because 5 divided by 1 would be 5. So then the slope is also 5. And in this context, it means he saved $5 per 1 week. These are the points that I use, the blue dot here and the red dot here. You could have also used this dot here at 260. You could use this dot at 680. Whoops, it's supposed to be all on that line. You could use the 890. Any of those dots along this line will work. You still just should get the answer of 5 for the slopes. So here's the answer to this second practice problem. Again, I used this blue point and this red point. When I subtracted the y values to find the change in y going down the y-axis, I get negative 100. It decreased from 200 to 100 going down, so that's why it's a negative number here. And then I subtracted 80 minus 0 to get 80 for my for my denominator. Along the x-axis, it moved 80 to the right, which was increasing, so it's positive. Then when I divided, I got negative $1.25 per 1 month. So the balance decreases by $1.25 each month. Again, you could have used different points along the line. These are just the 2 that I chose to use. Good job with those 2. I have 3 more problems for you. You'll notice that these do not have context with them. They are not talking about money or months or weeks. They are simply graphs. This one over here is taken right from your Khan Academy assignment that you'll do with this lesson. So this is just giving practice without context. Now that you know how to do it, how it makes sense, like $5 per week, $1.25 per month. Now let's see if you can find the slope of each of these graphs without that. And then also this last one is a challenge because it doesn't have a graph. You can't draw the triangle, but we can do is it's given you 2 points, just like we've used here. We've listed out our 2 points from our graph and then solved it. So it's just skipping this first part of a graph and going right to the points. So we still should be able to get that as well. So go ahead and pause the video and solve these last 3. So here we have the answer to the first one, number 3. The slope of this line is 4/3. In all the other examples, we've divided this to find a whole number. In this case, it'll come out to 1.3 repeating, which we know is a rational number because the decimal is repeating. But since this isn't exact, if you could put 1 to 3 into your 1.3 or 1 3/10 into your calculator, it's not going to be the same as putting 4/3 into your calculator. So instead of dividing it, we're going to leave it as this fraction greater than 1. But this should be our slope. It should be 4/3 for number 3. And this part down here, this is why we practice the subtraction of negative numbers at the beginning. Again, if you need a number line for that, you're allowed to use your calculator on this part, if that will help you too. But that's how we get 3 is 2 minus a negative. We know that that subtraction, you usually move to the left. But instead, we're switching because we're subtracting a negative, so we're moving back to the right. So 2 plus 1 would be 3. For number 4, the slope should have been negative 3. Again, I use these 2 points at 0, 4 and at 1, 1. You could have used this point down here at 2, -2. If you use this point, say right here, again, I don't know exactly what number this is going up, so I don't want to use that point. I want to use points that I know that are exactly on the faded lines in the back. This last one, number 5, should have been a slope or rate of change, right? These are synonyms, of 4. You'll see that I highlighted which of these are our x values and which of these are our y values at the bottom. Remembering when we're writing it as a coordinate with the parentheses and the comma in the middle, the x comes first. So our x and our y, we subtracted, we did the change in y divided by the change in x, and then when we solved all that out, the answer should have been 4. So hopefully you're getting those. Really proud of the hard work that you're putting in. I know that it's different learning from a video, but I'm really proud of the work that you're doing. Keep it up. Last thing before I go, just to check in to make sure we know these before we get into our Khan Academy assignments. Slope is the same as rate of change. Good. To find the rate of change, what do we have to do? Change in y divided by change in x. If we don't have points, we can draw them in, making sure that we know the numbers when we do that. And if we don't have a graph, we can still find the rate of change or the slope by the change in y divided by the change in x. So remembering all these things as we move forward. You only have 2 Khan assignments for this lesson, slope from a graph and slope from 2 points. So you've just practiced both of those. If it didn't make sense yet, you can go back and watch this video again, pausing as you need to. And remember, there's also videos on Khan that can help you too. You've got this. Show us what you know.